And
yeah, not maybe the people online, yeah.
Yeah, there are people online. Okay, right, so thanks everyone for coming. This is the first Melbourne RAGTAG meetup. I'm basically going to go through a really high-level intro of retrieval augmented generation. For those that already know, I'm sorry, but we can maybe have a little bit of a more in-depth discussion later on. I'm going to talk about applications of RAG and show you a demo of how I'm using it. And then at the end, because this is the first meeting, we'll have a discussion about like what kinds of meetings everyone wants to see in the future, and how we're going to structure the group, whether we want to meet here or maybe book somewhere in the city. This is the only slide I've seen demos. Okay. So firstly, LLMs, ChatGPT, Google Gemini, in some ways they're amazing. Other times they make really dumb mistakes, and also there's the knowledge curve. So if we wanted to know, say, what meeting room at Monash University, Building 60, 23 College Road, Clayton, then try it. It's one of those things where ChatGPT might not have knowledge about that specific detail. It's known as the Monash University Law Chambers. And when it doesn't, it has a tendency to hallucinate, make things up, which is in a way even worse than okay. So RAG, the idea is a couple of things. Firstly, it allows you to complement large language models with your own data, so that might be internal to your organization. Or it could even be sort of public information that just wasn't picked up in the large language model training data. I guess the final thing is also it's meant to help prevent hallucination, because the idea is we can tell it verified facts and then it should try and preference to use that rather than just making stuff up when it doesn't know, like this, where it's telling us that supposedly we're in the Monash University Law Chambers. If I run that, it'll probably give us another response. It's the science student match. Yeah, it's just... Okay. So the idea is we give a list of documents, or if you've got a longer document, you break it up into little chunks. For this demo, I'm just going to do 3, but imagine that there could be like thousands of chunks here. So in this case, I've put 2 facts that are kind of relevant to meeting rooms. The first one is the Monash Generator boardrooms located in Building 60. And the second one's like other meeting rooms, State Library Victoria, and then we have a bunch of irrelevant stuff like the Angie Likes Veggie Pizza. So one way around it would be you just feed all of that stuff to the LLM as part of the prompt. So we could have like a big prompt where it starts with all of this miscellaneous stuff that we know, and then we prompt the chatbot, the LLM, with our question. The problem with that is that once you have too much information, it might not fit in the context window. And even though context windows have got longer over time with the larger models, there's still the risk that the relevant information might be somewhere in the middle of that, so it's not necessarily going to pick it up. So what we really want to do is first kind of filter from all this gump what's potentially relevant to our question, And then we feed that as part of the prompt for that augmented part, and then we finally get that answer. Okay, so first part though, how do we get the relevant parts? So that's where embeddings come in. For this demo, I'm using OpenAI embeddings, but you could potentially do it yourself using something like, I think BERT has a special CLS flag, which will give you like a 768 dimensional embedding. But it's not the best. They've got variations of that that are specifically designed to make sure that, say, if two documents are about different topics, that they're far apart. So yeah, there's a sentence that you can fine tune a model. Just use OpenAI. Okay. So in this case, I'm just using the OpenAI embeddings API, and it gives us back 1,536 dimensional vector that sort of tries to extract sort of where
it's like the context of each.
Yeah, help me out. Yeah, the context. Yes, I like that word. Of our question, which was about the rooms at Monash. And regardless of how long our sentence is or how short, it will always be for the OpenAI embedding API. It will always come back with 1,006 dimensional vector, which allows us to compare things. So, like, if you got like different dimensions, say different lengths of text, that would be really hard to compare. Okay, so what I'm going to do is for each of those documents, so the chunks of text, we're going to generate an embedding for each of them. So one embedding, I'm not going to print that because that's also just another vector. And then we just want to measure the distance. Traditionally, cosine similarity, but it doesn't. I don't think it really matters which distance metrics you use, because all that matters is like close or is it far away. Okay, so let's try it out. So from document 1 to the question, 0.91 similarity. So this one, it was mentioning the Monash generated boardroom, and our question was about rooms at Monash, I think. Yeah. State Library Victoria, 84%. And then irrelevant information, like Andrew likes veggie pizza, only 0.71% similarity. So by doing this, we can sort of filter out anything irrelevant. Even if I hadn't actually used any of the exact words that were in the question, because as it's trying to extract out the context, like if instead of university I said learning place, that should still be embedded to a sort of similar coordinate and have high similarity. You might be wondering, okay, why do we need the LLM at all? Because this kind of already got it, right? The reason is, say I said like what meeting room is not at Monash University. Let's just stuff. I mean, it changed a bit, but you can still see that the Monash generator boardroom is the closest to that question. So we don't want to use just the embeddings alone. That's just going to tell us how close it is, and it's not going to be perfect. But the idea is that at least that tells us what information might be relevant, and then we can do a second stage. I'm just going to change that back. Okay, cool. You may have heard a lot about vector stores or vector databases. I'll be honest, I don't really understand the hype. All it does is just tells us what embeddings are close to the embedding of, say, our question. If anyone wants to defend vector stores, go ahead. But
I think it's because it can utilize parallel computing.
yeah,
That's why the height comes from. I thought.
Yeah, I guess it's about being fast and efficient.
Like retrieval was very quick.
Yeah, yeah. I don't quite get it though, because like, yeah, it's great to have it efficient, but it's the LLM that's the slow part that's using up your computation. So, like, unless you have a lot of documents in your embedding database, I'm not sure.
Also, one thing, like for example, you're using OpenAI embedding, and if you use some like a cheaper embedding, it makes a huge difference. So,
Oh yeah, the embeddings are definitely important, but I don't see why you need to use some specialized database rather than just do it yourself. Anyway, feel free to disagree. If you want to use a database, go ahead. In this case, I'm just using one of the lightweight ones that's built into LightChain, Chroma. Basically, it just does what we did above, where for each document, it's going to generate an embedding. In this case, we're telling it to use OpenAI. And then we generate a retriever, which just basically means that we're going to give it some sort of question or some sort of statement, and then it's going to come back with the closest embeddings. By default, it will find the 4 closest. You can vary it. Just for the purposes of this demo, I've changed it to 2, otherwise it'll just return everything. But you might want to play around with that in future. I think when I was looking at the documentation for this, there's also a few different strategies you can use. Like rather than getting their closest, they've got some where it'll deliberately give you varied examples, so you don't just end up with all your closest just being the same thing reworded slightly different ways. Okay. So in this case, you can see to our question, we got back the 2 closest documents, one being about the Monash generator boardroom, and the other one being state library meeting rooms, which are sort of relevant to our question. And then all the irrelevant stuff, like the fact that I like pizza, is removed. And then all we do is we feed that back to our LLM. So this is just for example. Obviously, you'd want to maybe check what the standard prompts are, or iterate on this yourself to find what gives the best answer, or possibly even fine-tune it. So in this case, just basically give both of the documents that we retrieved as potentially relevant as the context here. And then finally, we ask the large language model our question. And yeah, really, that's basically RAG in a nutshell. Hopefully, that works. That Monash generated bedroom is the Monash generated boardroom. Yes, that is where we are. And change this to not. Let's run the whole thing. What you like just by itself, it obviously doesn't really know. So do this. Cool. So we end up with the exact same documents as our context as potentially relevant, but our is then able to interpret that, and in this case, because we said not, it picks the other one. Cool. Is there any questions or things people want to discuss before we move on with applications?
Pretty
cool.
Anyone online?
Yeah, it's a little bit awkward because we've got some people who've spent lots of time on it and some people that might be new. So
I am kind of new, but
Okay.
probably for the last 3-4 weeks, been pretty much studying it non-stop.
So this I think is sort of the most basic version, but then there's sort of lots of variations. Like some of them they say you take your question and then you reword it multiple ways.
With like prompt templates and all of that.
Yeah, or rather than using the embeddings, the option is you take your documents and you sort of extract out a graph, and then you get the nearest documents that way. So
knowledge graphs.
Yeah. So we were thinking, we'll come back later. Like maybe for the next session, we could discuss a little bit more advanced in-depth approaches.
So what kind of text embedding are you using here? I saw you use like some OpenAI.
Yeah. So for this one, not to be confused with the OpenAI large language model. OpenAI provide an API where you can send it some text and it'll come back with a vector representing it. So it's sort of the easy way, but you can.
Is it similar to Word2Vec or something like that?
Yeah, exactly.
Right.
I think Word2Vec though, it's usually just a word, whereas this is like an entire sentence or paragraph gets converted to a vector.
Okay. And I saw you use like some cosine similarity or something to compare this embedding. So is the retrieval algorithms basically similar to like KNN or something, but running on the embedded space?
Yeah, in fact, it's like KNN. So in this case, we were doing sort of 2 KNN where we retrieve the two closest. There's variations, but that's the simplest one.
When you spoke about the embedding, so it's not on like a token level that has its own vector store. It's the sentence you said.
Yeah. So in this case, our question was this
the whole query,
sentence, paragraph, whatever it is. But the embedding we get back is always this fixed number of dimensions. So even if we fed in a whole novel, we'd still just get back a dimensional vector. But what they recommend is like if you have something long, you might break it up into chunks because
that's what I was. That's what I know about that. I was thinking like, so is the sentence you're talking about a chunk?
Okay. I was a little bit lazy in this case in that we didn't do chunking. I just treated everything as a single chunk. But you're right. Like if you had so like if this were like a novel,
and then you chunk it. Because the models or what I've been playing around with when I chunk it, I've been using llama index, and the chunks I get are usually paragraphs. Like, does the effectiveness of the RAG system or the pipeline change based on the size of each chunk?
I don't know. I think, it's a little bit
because I feel
different.
like context might be lost. If it's on a sentence level, you might need like 4 or 5 sentences to retrieve, I guess.
So I'm talking not from experience here, but just my guess is that what matters is the ability to come back with documents relevant to the question. So I think if the document, even if it was very long and it was just all talking about my love of veggie pizza, that would probably be okay because that whole thing's just talking about a single thing. But if it was talking about veggie pizza and all kinds of other foods, then maybe by splitting it up in like every fact ideally would sort of be its own chunk.
Yeah. And so when that's retrieved,
so otherwise, because the entire thing has to just have a single embedding, which is sort of a single context, but really like a document, it could discuss lots of different topics, in which case it makes sense to break it up.
So when it's retrieved, it goes into the prompt. What decides what documents go into the prompt? So
yeah, that's
is that
another
k equals
good
2?
reason for.
Or is that just showing k equals 2?
Okay. So for this example, I've set k equals 2, so it'll just take the two most relevant, whatever they are. In reality, you'd use a larger k. I think 4 by default, but you could use something larger. But yeah, that's actually another good reason to do the chunking, is because when we do the context here, like if one of these were a really long document, then that entire document would end up in the context. Whereas if you've broken the document up into chunks, then we'll just see the relevant chunks of the document here. As for what chunking strategy works best, like should it be a paragraph, 2 paragraphs, how long?
Yeah,
I don't really know, and I think you'd have to empirically try it. I think as recently reading a paper, Microsoft GraphRag, where they talk about their chunking strategy, and they talk about like should you use shorter chunks and longer chunks, and also the trade-offs involved in that you don't want to make too many prompts. They just do it empirically, but also that's sort of a slightly different strategies. Okay, I think I'll maybe move on to how we're using it. Okay. Cool. Okay, so as a demo, what I've done is set up a bot that anyone should be able to say post a request or an offer for something, and then the bot will use RAG underneath to sort of find the most relevant post. So for example, here's a not so hypothetical one. So I was looking for a meeting room, and then bot comes back and finds uses RAG to look through all the other posts people have made and come back with hopefully the most relevant one. So in this case, it wasn't so great. It came back with a spare room, so it didn't understand that it was a meeting room versus a bedroom, but you get the idea. I think for those online, you're probably not going to be able to see my terminal. I'm just going to monitor the server so we can see what it's doing in the back. So let's say and then hopefully the idea is the bot will see this post, look through, in this case, say everyone's requests and sort of connect me to, well, in this case, myself. Ideally, we'd have multiple people, someone looking for a meeting. Demos are always. I think I just need to refresh the page. There we go. Looking for an available CVD. Tag me. I should. Sure if I should show my credit history, but it gives me a notification. Ideally, what I want to do is set up like my own platform for this, but I don't want to replicate social media, so it's just using Reddit for the example for now. It's a little bit hard to see if I can share my terminal. Okay. Okay, so in this case, it came back with from the vector store. We got the meeting room, but also a bunch of irrelevant stuff like I need a logo for AI ragtags. I'm not sure why it thought that was similar. And well, share house, I guess that's kind of related to rooms. And then because even if you get some things that aren't 100% relevant, that's okay because the large language model is just going to see that and it comes back with its answer. But you don't want to get too much because then you'll end up with a really long context window, which is going to cost more or possibly even run into the limits of how large your context window can be. Any questions or thoughts about the demo? Or I guess, is anyone else using RAG for certain?
That's cool. That's
Cool, thanks.
I understand what's going on under the hood, but how is the server monitoring or how is the application monitoring a Reddit board? Is that just like?
Yeah, so for this, I'm just using Reddit's API to monitor for any new posts that come in.
Okay.
And this is just renting out an AWS virtual machine.
Yeah.
So I just have it continuously streaming. And so whenever, it's a little complex because there's offers and requests. So whenever a request comes in, it gets indexed in the vector store. And offers get indexed in a separate data store. And then when the new post comes in, I'll look. So in this case, when the offer comes in, I look through the vector store of any requests and match them up. Or if it's a new request comes in, I look through the vector store of the embedding store for the previous offers and match them up. And then I haven't fully implemented it yet, but ideally it would be a two-way thing. So
it's better than anything I've made so far. So
let's see. Like that's simple example of how we can use it. I got blocked from Reddit the first time I tried this because I had some bug where I was just posting the same thing over and over again. But so be careful with what account you use it on. If you want to try out the code, it's a throwaway. Yeah. Yeah, and if you have any questions on this, feel free to sort of spam it because we'll use this to sort of inform our next iteration and sort of test how well it's working in practice. So, like, one of the things we've noticed already is there's a lot of stuff around location. And so maybe the RAG's not enough. Maybe we need to complement it with some sort of hard-coded approach to maybe take care of the location and then compare both what we know about locations with what the RAG's telling us. So, yeah, it's not perfect, but it does a surprisingly decent job of at least getting something that's kind of related. I'm not sure how it's gonna work though as we scale up.
Yeah, right now you see like some of the posts came from New York and all like, and yeah, right. So
Yeah,
location
so
would be really important if you do something local selling.
I don't know who this is, but
Yeah.
yeah, so
Yeah, I think if we create a profile and then we put our locations and stuff, if it had access to those things, and then we can prompt it to understand that context. So yeah, like if you have any thoughts, like how you can develop it more, or like what you would do, like if you have this concept, given like kind of thing where you have a system like this and you want to match it up, how do you use the rack system or any other system if you want, like
yeah, so I think Anupam, you're researching RAG, right?
Oh,
From the algorithm side.
say like yeah, I just wanted like if I yeah, I would like if it is a matching problem, then I would use like I will like yeah, as those kind of message and offer come, everything would be embedded in a vector thing, and then I would say that that is your context, and then your kind of your prompt is to like to match each other based on the context, offer and request, or some certain things. And then maybe if we have access to now, I think like okay, look, if I can create a graph database where the user making a post, then we have access to the user address and stuff, and you have the post, then like we could like take in the context of the user address, and then the post is about say moving companies and all, then we could only match up with a moving company that is close to that kind of address, like not elsewhere. So those things.
It gives you like more context in a graph. Yeah, I get what you mean.
And
like there's a lot of other applications of RAG, but I think like by actually working on something concrete, it sort of starts, well, with anything really, it starts to reveal the limitations of the existing algorithms and this isn't actually a fully solved problem.
So like that sort of motivation, like mostly still right now out there you will see most of the recommendation algorithm would be based on still keywords, like not on a context kind of, like for example if you're doing say even the Stack Overflow or Stack Exchange or Math Overflow, then even there also if you see like the recommendation of the post similar don't really understand what is the answer or the questions thing, and if really can understand, then it will be giving you a way better recommendation. Right. I mean the whole Google is kind of built up because like I mean they have a page ranking algorithm, and that's like was and they kind of got so good, right?
Indexing. Google basically came up with indexing, right? Yeah.
Right. Yeah.
Cool. So I think that pretty much ends sort of the demo part of the talk. I guess like we can always talk about ideas and things around that later. The last thing I wanted to get through today is just sort of planning for what talks next, get people's feedback, think about sort of structural things like, do we want to keep on doing it here, online, city? So for coming so for upcoming talks, I think next one we were thinking of doing an introduction to LangChain, understanding the syntax there, how like everything I did in that notebook can be done a lot more elegantly in LangChain. And then that also just sort of gives us the language we can easily implement the sort of more advanced RAG strategies and different variations. I think that would be either myself or I think Anita's been looking a bit into that. I'm not going to put you in the spot. Okay.
I am actually learning new things, so yeah.
Yeah, well, I only found out about query pipelines in Llama Index a couple of days ago, and then
has it? I haven't used Llama Index before. So.
oh, okay. Well, it seems really strong. Like 3-4 lines of code can create a whole pipeline. Obviously, the models have to be predefined and everything, but there's like you can do the prompt template, feed that into through a RAG system, go through another LLM, output parser. There's honestly like the sky's the limit in terms of
yeah, it seems
the
like
amount of things you can hook up.
Yeah, it seems like a lot of overlap maybe then between what LangChain does and but like as a group we're not tied to any
yes, so we should you could teach us Llama Index
so,
and we will be
I was thinking with the talk Ravi, if you're online, sort of indicated that maybe he was interested or if anyone else has been looking at Llama Index, it would be interesting to have a talk on that, see how it differs to LangChain. I know LangChain isn't just about RAG, it's just about creating. So it'd be interesting to see, like, for someone getting started, like which would be the right one to recommend and which works better in practice and that kind of stuff.
I think they both have. I know nothing about LangChain compared to you guys, but I think from a one-page article I read a couple of days ago that LangChain, like you said, is more generalized and Llama Index is more focused on the RAG and the whole indexing and
that sounds like it could be right. I haven't actually used Llama Index yet.
Yeah, so actually we are all students learning together, so that is kind of the concept here.
Cool. So does someone you don't have to do it now, but if you'd like to volunteer for a talk.
So just one thing, like, okay, so these are all the, I think, application bit, but I thought like some point I will also kind of go for transformer architecture if anyone want to listen to it, but if not, I'll not go.
I'm keen on that. I like.
I mean, mostly talking about the self-attention paper in depth, but as I really like it, and though it has nothing to do with the application, but I think if you understand the code bit, then later if something goes wrong, maybe it will help us in some way. So if you're interested, then only I will talk about it, and we can go about like the transform architecture, the positional encoding, and later the whole entire model, like the encoder model. Is anyone online? I'll let.
Is the we still online?
We are still online, okay.
Sure. It'll be recorded. Could for anyone that's still online, could we maybe get a feel for like background is in terms of like have you studied this stuff in uni at depth? This little new just so we get a feel for what kinds of talks might be.
Well, for me, I'm still in my master's. Probably the least qualified of everyone here. In our entire group.
Master in what?
Data science.
Master in data science, like Manesh?
Yeah, just to me that means you've probably got quite a lot of.
So you're in first year or second year?
Second. I'm pretty much finished. I'll be finished by next year.
So you're in the third semester, fourth semester, next year, the fourth semester?
Yep.
Oh, cool. So you're doing by research or by
What was that, sorry?
master's by research, or you're writing a thesis, or?
Data science. I haven't decided. I can do the thesis,
Okay.
but the thesis would be good, but it will add an extra semester onto my degree.
Okay.
Because I think there might be a stream where you can do a research thesis in one semester.
Mhm.
But I think most of them are 2 semesters. Robbie, if he's still here, would be able to correct me on that.
Okay, Robbie, are you there? No, Robbie's not there.
But yeah, the last, I guess, I've always had like an interest in the LLMs and around this space, but the last 3-4 weeks, I've really started to question: should have I not done data science and more like gone towards the AI? But they're pretty like overlapping.
It seemed pretty close to me.
Yeah, they are very.
I mean, so you are kind of interested in the, at least for now, in the deeper area, like kind of more the
More Gen AI, yeah.
Like what do you mean more Gen AI? Like you are interested in the
Well, Gen AI, it's sort of only become popular in like the last 1 or 2 years, so it may just be the courses on it yet.
Yeah, well,
it might not be part of their standard course structure yet.
Most of my study in my master's has been, so we did a machine learning unit, just understanding that most of the algorithms on a very low level, gradient descent, all mathematically, backpropagation, even GPR. I don't know if you guys have done GPR, Gaussian process regression.
Okay.
Which seems pretty computationally intensive. I think the complexity, O complexity time is like n cubed. But it's more, most of my studies has been around the wrangling side of things, visualization side of things.
Yeah, that's the reality.
The reality side of things, yeah. But yeah, I'm finding a lot of this stuff a lot more interesting. And I'm also finding that it's not complete waste. Like there's a lot of overlap at least what I've done and how it's helping towards
gradient descent.
Should we not record it or like in the meeting?
Okay, yeah, let's wrap up the final part of the formal part of the meeting, and then we can end that.
We can talk more.
Okay, so yeah, I guess maybe we'll do a survey online later, but it seems like there's a lot of interest in sort of going into a lot of depth on the research part, and it seems like a lot of people are interested in. This group doesn't have to be strictly about RAG, but at least the first 2 topics I put around that, and particularly because with large language models, it's very hard to compete directly with, say, OpenAI because it costs millions of dollars to train.
Yeah.
But then there's a lot of stuff you can do around that, like in terms of RAG or agents, and it can actually have quite a big impact.
Yeah, I think no one is online anymore, right? Yes. We could just close the recording.
Yeah.
Finish it.
Any last remarks before we? Last week.
Is this still online?
Oh yeah, it's still online. Just before I stop that.
No, you can stop it.
Okay, cool. Thanks everyone. And yeah, this should be uploaded.
Okay, see ya.
Oh, see. Any last comments, we?
No. It was a nice meeting. Hopefully I can attend the next one as well.
Yeah, thanks for joining. And yeah, we'll be in contact on the Slack group.
Okay, thank you.
Okay.